Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about full subtractor and the RTL design implementation of full subtractor by using basic logic gates, and RTL design implementation of full subtractor by using two half subtractor. As in my previous video, I have already discussed about half subtractor, that it is useful for subtraction of two binary numbers and it gives us a difference and borrow out. But half subtractor don't have borrowing from the previous subtraction. So to overcome this issue, we have now full subtractor. Basically, full subtractor is designed to handle three inputs. The first input is minuend, means the number we are going to subtracting from. Second input is subtrahend, the number we are going to subtract, and the third input is borrowing. Okay, this allows us full subtractor to be used for multi-bit subtraction. Now if I talk about block diagram of full subtractor, so three inputs, it can be A, B and borrowing. A can be minuend, B can be subtrahend and borrowing, and it has two outputs, that is difference out and borrow out. And we know that difference out is used to store the result of subtractions, and it always computes by using an XOR gate. That means difference out is equal to A XOR B XOR borrowing, and borrow out is used to store the result of borrow out, and it always computes by using an AND gate between two inputs, that is B and not of A, or with B and borrowing, or with borrowing and not of A. If I talk about truth table of full subtractor, so if all three inputs are 0, then difference out as well as borrow out are low. If A is 0, B is 0 and borrowing is 1, so that means 0 minus 1, so result will be difference out is 1 with borrow out. So my borrow out is also high, because we can't subtract 1 from 0 directly. Now if A is 0, B is high and borrowing is 0, again same condition, it is 0 minus 1, so my difference out is high and borrow out is high. Now if A is 0 and B is high and borrowing is high, so it is 0 minus 1 is equal to minus 2, equivalent to difference out is equal to 0 with borrow out is equal to high. Now if A is high and B and borrowing are 0, then 1 minus 0, 1 only, so difference out is 1 and borrow out is 0. If A is high and B is 0 and borrowing is high, so 1 minus 1, obviously difference out is 0 as well as borrow out is also 0. If A is high and B is high and borrowing is 0, so 1 minus 1, 0 only, so difference out is also 0 and borrow out is also 0. Now if all three inputs are high, then obviously difference out as well as borrow out both are high. Okay, now let's jump for the RTL design implementation of full subtractor by using basic logic gates and by using two half subtractors on a Vivado tool. So you can see my screen, this is the Vivado tool, and I have already written a code for the RTL design implementation of full subtractor by using basic logic gates. So let's go through the code. Module name is full subtractor. We are having three inputs, A that is minuend, B that is subtrahend, and then borrowing from the previous subtraction. Output we are having difference out and borrow out. I have assigned A XOR B XOR borrowing to the difference out, as difference out always computes by using an XOR gate, and I have assigned not of A and B or with B and borrowing, or with borrowing and not of A to the output borrow out. So if I'll click on this schematic, so here you can see difference out computes by using an XOR gate between A with B with borrowing. Okay, and borrow out computes by using an AND gate between not of A and B, or with uh, B and borrowing or with borrow in and b. Okay, now to verify this full subtractor, I have written a simple test bench code also, so we'll go through that code. My module name is testbench full subtractor, and these are the input and output variables. Same, the number of variables. I input A, B, borrow in, and output borrow out, difference out, and borrow out. Here I have taken an instantiation of full subtractor. Okay, and inside the initial begin, I have given 8 combinations. As we are having 3 inputs in full subtractor, so total 8 combinations become. So I have given the values as per that. Okay, now we'll see the waveform. As I have already click on this united. Okay, now as I already explained you in the truth table, if A, B and borrowing both are low, then difference out as well as borrow out are low. Now if A is low and B is low and borrowing is high, so 0 minus 1, although yeah, difference out is high, but with borrow out. So here my borrow out is also high. Again A is low and B is high and borrowing is low. So again it is 0 minus 1. uh, in directly we can't do directly we can't subtract 1 from 0, so my difference out is 0 but with borrow out. So again here my borrow out is high and difference out both are high. Now here low and b is high and borrowing is high, so 1 minus 1 0, that means difference out is 0 but borrow out is high. Okay, now here my A is high, B is 0 and borrowing is 0. So 1 minus 0 possible. So difference out is high. 1 minus 0, 1, difference out is 1. We don't need here borrow. So borrow out is low. Again A is high, B is 0 and borrowing is high. So you can consider 1 minus 0 minus 1. Indirectly 1 minus 1, difference out is 0 as well as borrow out is also 0. If A is high, B is high and borrowing is low, so again 1 minus 1 0, so difference out and borrow out both are 0. If A, B and borrowing both are high, both of three, all three inputs are high, then difference out and borrow out both are high. Okay, now let's jump for the RTL design implementation of full subtractor by using two half subtractors. So here you can see I have already written and Verilog code for the RTL design implementation of full subtractor by using two half subtractor. So let's go through the each line of code and understand. My module name is full subtractor using half subtractor. Inside this module, first I have include half subtractor. So first we'll go to this file. So here inside this file I have written code of half subtractor, which are having two inputs A, B and two outputs difference out and borrow out. Okay, I have assigned A XOR B to the difference out and not of A and B to the borrow out as per the functionality of half subtractor. Again here another module I have taken, that is borrow output. So inside that what I input I have taken borrow in 1 and borrow in 2 and my single output borrow y out, and I have assigned borrow in 1 or with borrow in 2 the output y out. Okay, now I have taken both the instantiation to the this module, the top module, which is full subtractor using half subtractor. Now it has three inputs A, B and borrow in. As I told you, A is minuend, B is subtrahend and borrow in. And output we are having two output, that is difference out and borrow out. Okay, now I have taken three wires. The first wire is first subtraction borrow out. Second wire is second subtraction borrow out. Third wire is first subtraction difference out. Now you can check my this is the first instantiation of first subtractor, that is half subtractor, first half subtraction instantiation name. Now I'm assigning first two inputs, that is A and B to the first half subtractor, and I'm getting output of difference out to the output first subtraction difference out. In this wire I'm getting output from the first half subtractor, and the borrow out I'm getting in output inside the first subtraction borrow out. Now what I'm doing, I'm assigning the first difference output of first half subtractor to the input for the second half subtractor. So you can see my dot A of first subtraction difference out, and my third input, that is borrowing to the second input B, and here also we are getting output difference output. That is our final output. Okay, difference out. And from this is the second half adder, so from second half adder we'll get the second subtraction borrow out, and both the first subtraction borrow out and second subtraction borrow out is going as an input for the borrow output is the third module. Okay, and here you can see borrow in one and borrow in two. So I have assigned first subtraction borrow out and second subtraction borrow out, and the last output is borrow out. So this is the final borrow out. Now if I click on this schematic, so there you can understand. Here you can see this is my first half subtractor, where to this first half subtractor, my input is A and B, and output is difference out and borrow out. Now this difference out is going as the input for the second half subtractor, and it will do the XOR operation with difference out and borrow in, and the final result will be here in difference out. Now the borrow out which will come from this first subtraction and second subtractor, that will be OR with in this model, and will give the it will give the result inside the borrow out. Okay, now to verify this first full subtractor using half subtractor, I have written simple TB code also. So we'll go through the TB code. My model name is TB for full subtraction using half subtractor. Okay, and these are the variables, input and output variables, that is A, B, borrow in, and difference out and borrow out. Now this is the instance of a full subtractor by using half subtractor. Okay, I have instantiated, and inside the initial begin I have given 8 combinations as we are having 3 inputs. Okay, now if I click on this run simulation, so we'll see the waveform now. See, as per the truth table, if A, B and borrow in are both all 3 inputs are low, then difference out and borrow out are low. If A are low, B are low, and borrow in are high, so 0 minus 1, as we can't directly subtract 1 from 0, so difference out is high with borrow out. So here you can see borrow out is also high. Now here A is low, B is high, and again borrow in is low. So again the same conditions here, 0 minus 1, so difference out is also high and borrow out is also high. Now A is 0, B is high, and borrow in is high, so this you can imagine 0 minus 1 minus 1, decimally it is equivalent to minus 2, but difference out is 0. Minus 2 means is equivalent to difference out is 0 and borrow out is high. Now here A is high, B is low, borrow in is low. So 1 minus 0, obviously difference out is high and borrow out is 0. Again A is high, B is low, and borrow in is high. Means 1 minus 0 minus 1. Indirectly you can say 1 minus 1 is 0. So difference out is 0 and borrow out you can see 0. Again here A is high, B is high, and borrow in is low. So 1 minus 1 0. So difference out is 0 and borrow out is 0. And if A, B and borrow in both all 3 inputs are high, then the difference out and borrow out are high. So here I'll stop the video. So basically in this video we have discussed about RTL Design implementation of full subtractor by using basic logic gates, also by using two half adders, two half subtractors. So if you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please click on the subscribe button. Thank you so much.